Hey you guys, this is Mr. Millings, and in this video we are going to learn about the combined gas law. So what is the combined gas law and how does it work? Well, it says right here that the combined gas law is a gas law that combines Boyle's law, Charles' law, and Gay-Lussac's law into one easy formula in which three variables of a gas, pressure, volume, and temperature are taken into consideration. So in an earlier video, we learned about Boyle's law, right? And Boyle's law states that if you hold the temperature of a gas constant, then the pressure and volume of that gas are going to be inversely proportional. As one increases, the other is going to decrease. And then we learned about Charles' law, right? And Charles' law states that the volume and temperature of a gas are directly proportional. If the volume of a gas is doubling, then that's because the temperature of the gas is doubling, etc., etc. And then we learned about Gay-Lussac's law, and he states that at constant volume, the pressure and temperature of a gas are going to be directly proportional, right? That if the pressure is increasing, it's because the temperature is also increasing. If the pressure is being cut in half, then that's because the temperature is also being cut in half. So we learned about Boyle's law and Charles' law and Gay-Lussac's law in other videos, and we learned how to solve problems using the formulas that you see right here. But wouldn't it be cool if there was some sort of formula out there that somehow combined all three of these gas laws into one easy to use formula? Do you think there's a formula out there that combines all three of these formulas into one? Well, if you're thinking yes, there is, you're absolutely right. And that is the combined gas law. And that's what we're going to talk about in this video. So let's take a look at the combined gas law and see how it works, and then apply the combined gas law to several different types of problems. So what we're looking at is the combined gas law. The combined gas law tells us that P1V1 over T1 equals P2V2 over T2. So when we're working with the combined gas law, we're taking a look at three different variables of that gas. We are taking a look at the pressure, volume, and temperature of that gas, and what will happen to that gas's pressure and volume and temperature if we start to manipulate some of those variables. And it says right here that when working with the combined gas law formula, all pressure and volume units need to be the same. And last but not least, the temperature needs to be in Kelvin. Okay, so when we're working with the combined gas law, all temperature units need to be in Kelvin. If we're working with milliliters of gas here, then we need to be working with milliliters of gas over here. If the pressure over here is in atmospheres, then we need to make sure that the pressure over here is also in atmospheres. Okay, so here's your combined gas law. The original pressure of the gas times the original volume divided by the original temperature is going to equal the final pressure of the gas times the final volume divided by the final temperature of the gas. So let's go ahead and use this combined gas law formula now to solve different problems where we have some changes in one of these variables that we see in front of us. In this first example, it says a gas occupies 40 liters at 1 atmosphere and 200 K. How much pressure? So we're asked to find how much pressure will the gas exert if the temperature increases to 400 K and its volume decreases to 20 liters. So when we come across these word problems, what I like to do is go through and go ahead and label everything. And so let's take a look at what the gas is all about. Starting off, if we take a look, the gas is occupying 40 liters starting off, so that's going to be your V1. It tells us that the pressure of this gas starting off is 1 atmosphere, that's going to be P1, and the temperature of this gas starting out is going to be 200 K, so there's your T1. The question here is asking how much pressure will the gas exert if the temperature is going to change and increase to 400 K, so this is going to be T2. Its volume is going to decrease to 20 liters, so here is your V2. And we're asked to solve for P2. So here's our formula right here, but let's go ahead and list everything. We have P1, V1, and T1. And if we take a look right here, the original pressure of this gas is going to be 1 atmosphere. If we take a look, the original volume of this gas is going to be 40 liters. And if we take a look, this is already in Kelvin. Remember, when we work with this, temperature always needs to be in Kelvin. If it's in degrees Celsius, we need to make that conversion, but this is in Kelvin already. This is 200 K. Furthermore, if we take a look, let's figure out what's happening here. Let's figure out P2, V2, and T2. And so what we're looking at right here is that the pressure is increasing. I'm sorry, the pressure is what we're trying to find. We're trying to figure out the new pressure of this gas when the volume is decreasing to 20 liters. So the volume over here is going to be 20 liters. If we take a look at T2, it looks like the temperature is increasing to 400 K. So now that we have all this laid out, the formula that we're going to use to solve this problem is P1V1 over T1 equals P2V2 all over T2. And it looks like that we're trying to solve for P2. So what I like to do is I like to get rid of the fractions here. And so what we can do is we can cross multiply to get rid of our fractions, right? We can cross multiply to get rid of these fractions. And if we do so, we're going to end up with P1 V1 T2 equals P2 V2 times T1. And in this problem, we're asked to solve for P2. We want to get P2 all by itself on one side of the equal sign, so we're going to divide both sides by V2 and T1. And so it looks like the formula that we're going to use to solve this problem is going to be P2 equaling P1 V1 T2 all over V2 times T1. So now that we've done all this work, we've done all this algebra to isolate our variable, we can just plug these numbers in. P1 is going to be 1 atmosphere times V1, which is 40 liters, times T2, which is 400 K. And then we're going to end up dividing this by V2, which is 20 liters, times T1, which is 200 K. And so when we put this in our calculator, we are going to end up with an answer of 4. For what though? Let's take a look. Kelvin cancels out. Liters cancels out, leaving us with atmospheres. So the new pressure of this gas is going to be 4 atmospheres. Let's take a look at another example. In this second example, it says the pressure of a gas increases from 500 torrs to 800 torrs, and its temperature decreases from 75 degrees Celsius to 50 degrees Celsius. If the final volume of the gas is this right here, then calculate its original volume. So if we take a look, we're asked to calculate the original volume. Original means first, and so we're asked to find V1 in this problem. And so if we take a look, let's set everything up. Let's find out what P1 is. Let's find out what V1 is and T1. Let's figure out what P2 is. Let's figure out what V2 is. Let's figure out what T2 is. And then we can plug it into our formula. So the pressure is going from this to this. So here is our P1, 500 torrs. P2 is going to be 800 torrs. If we take a look, we're asked to find the original volume, so that's what we're trying to find. The final volume, it tells us, is 125 milliliters. T1, if we take a look, is going to be 75 degrees Celsius. However, we have to convert this to Kelvin, right? So to get our T1 here, we take 75 plus 273, and we're going to end up with 348 K. We have to convert it to Kelvin before we can plug it into our formula. To get T2, we have to take 50 degrees Celsius plus 273, and we'll end up with 323 K. So now that we have all these numbers, we can plug them into our formula. So if we take a look, here's our combined gas law formula. And so what we can end up doing is we can cross multiply to get rid of our fractions here. Nobody likes fractions, so we can cross multiply. And if we cross multiply, we will end up with P1 times V1 times T2 equaling P2 times V2 times T1. We're asked to figure out what V1 is, so we have to divide both sides by P1 and T2. These will cancel out on both sides, and so the formula that we're going to use to solve this problem is V1 equals P2 times V2 times T1 all over P1 times T2. So here we go. Let's plug these numbers in here. P2 looks like it's 800 torrs times V2, which is going to be 125 milliliters, times T1, which is going to be 348K. We're going to divide this by P1, which is 500 torrs, times T2, which is going to be 323K. And when we put this all into our calculator, we will end up with 215 what? Well, torrs is going to cancel out. Kelvin's going to cancel out, leaving us with milliliters. So the new volume, the original volume of our gas is going to be 215 milliliters. Let's take a look at another example. In this third example, it says if 50 liters of a gas exerts a pressure of 1.5 atmospheres at 25 degrees Celsius, then what will its new temperature be if its volume decreases to 20 liters while its pressure triples? So if we take a look right here, let's figure out what's going on. Let's go ahead and label all these little variables here that are in this word problem here, and then we can go from there. So here we go. Let's take a look at what's happening in this little word problem. It tells us that we have 50 liters of a gas starting out, so that's going to be V1. It's exerting a pressure of 1.5 atmospheres, so that is going to be our P1. And its temperature is 25 degrees Celsius. So temperature needs to be converted into Kelvin. We'll take 273 plus 25, and we'll end up with 298K as our T1. So T1 is going to be 298K. Let's read on. We're asked to figure out its new temperature. We want to figure out T2 apparently. It looks like its volume is decreasing to 20 liters. And what's happening to its pressure? The pressure here is tripling. The pressure here triples. So if this is the starting pressure and this triples right here, then 3 times 1.5 is 4.5 atmospheres. So there we go. We're asked to solve for T2 now. So if we take a look, we can cross multiply to get rid of these fractions. Nobody likes fractions, so we're going to cross multiply. And what we're going to end up with is P1 V1 times T2 equaling P2 times V2 times T1. And so now we're asked to solve for T2. So we're going to divide both sides by P1 and V1. P1 and V1 are going to cancel from the left-hand side, and so T2 is going to equal P2 times V2 times T1 all over P1 times V1. And so now we can just start plugging these numbers in. The pressure units are the same, they're in atmospheres. The volume are both the same, they're in liters. And we have our temperature in Kelvin, so let's plug these in. P2 is going to be 4.5 atmospheres times V2, which is 20 liters, times T1, which is 298K. And we're going to end up dividing this by P1, which is 1.5 atmospheres, times V1, which is going to be 50 liters. And so when we put this all into our calculator, we're going to end up with 358K. As we see here, liters is going to cancel, atmospheres is going to cancel, leaving us with Kelvin. So what is the new temperature of this gas going to be? It looks like the new temperature is going to end up being 358K. So if you like what you see, go ahead and click that little bomb in the bottom right hand corner, and that will subscribe you to my YouTube channel. And feel free to leave any comments or questions down in the comment section down below. And I really hope you guys found this helpful.